All right, welcome back to Mix Francis's YouTube. I know that you just love watching me ramble. For today, folks, we're going to take a look at the beginning of Lesson 7 in the How Things Fall packet. This is our lesson on calculating force and acceleration. Okay, so to get started, I want you to think back to Lesson 3 or pull out your Lesson 3 and just take a second, jot these guys down. Okay? Cool. I'm going to let you do that. No, that's not really why you're here. Here's what I need you to have. Calculating force of gravity, guided practice. That's why we're really here. What is the mathematical relationship, also known as the equation, between mass and gravity? Let's get that jotted down. I love that I gave you all of this, but not the equation. Good job, me. Your equation here is that force of gravity equation, so F of grav equals G times the mass of the first item times the mass of the second item divided by the distance between them squared. Okay? Cool beans. In this instance, we're looking at gravity on Earth. So that means the mass of one of these items is the mass of the Earth. Okay? You got to use it. So I'm going to go over question number 1 right now. And let's see if that helps us out a little bit. Okay. The first thing that you need to know about how we set this up, literally fill in the equation that we just wrote, is how we start this. Then we'll put the numbers in. Then we'll actually give you an answer. Okay? This is something I encourage you to try for the first time or two. And then from there, if you're like, okay, I got this, then you've got it, you can move on. If you're like, nope, you know where the scrap paper is in here. So for our equation, again, we have the force of gravity equal to G times, and this time I'm going to write ME, mass of the Earth, times MI, the mass of the item. Not great from the... Will you autofocus, please? There we go. Divided by the distance between them squared. So now we've got to plug in our numbers. This right here is what I need you to do. 3B is like the killer part of this for people. Y'all, we are playing connect the dot. So if you see the value for G, you're going to plug it in where G goes. The value for the mass of the Earth, that's ME, goes in where the mass of the Earth goes. The distance, D, goes where D is. This is your item, 71 kilogram student. So you're going to put that in for the mass of the item. That's the plan. That's all you have to do is just match stuff up. All right? What that looks like when we actually write it out is a big, big group of numbers. So I'm going to write that out for you, and I do apologize because it's going to take a second. So 6.67 times 10 to the negative 11th. And yes, you do have to write that massive unit. It's okay. It's good practice, and it will not hurt you. And Newton meter squared per kilogram squared. This is your value for G. Times the mass of the Earth. That's given to us up here, 5.98 times 10 to the 24th power kilograms. I'm going to put these in parentheses just so we can tell that this is one number. Times what's the mass of our person? 71 kilograms. Okay. Are we done? No. Got to divide still. To divide, we're going to divide by the distance from the center to the Earth to the surface. So you also might hear this called the radius of the Earth, right? Because remember, your radius is the distance from the center to the rim of a circle. So we are looking at that radius. That's 6.38 times 10 to the 6th power. And I know it's a little blurry on the video, but I will write it nice and clean so you can see it well. Okay? So that gives me 6.38 times 10 to the 6th power. See how nice and easy that is to see? Meters squared. Okay? Lovely. So then we're going to put this into our calculators. I will tell you that putting this in the calculator is probably the hardest part of this. If you can set this part up for me, I am happy to help you put it in the calculator. I am not the calculator patrol. Okay. I'm sorry about that really horrible noise. I should have paused the video there, and I didn't think about it. Okay, but here's my calculator, so let's get numbers going. So I always put a parenthesis in when I do scientific notation, just so that I can keep track of where I'm at. On this guy, the exponent is this little button. To do a negative, it's usually in parentheses, so it's this guy. 10 to the negative 11th. I'm going to come down and close my parentheses. Remember, when we're using parentheticals, we don't have to add a times in there. You can just add the next number. So our next number is 5.98 times 10 to the 24th power times 71, which is really easy to put in the calculator. I like to, if I'm using a calculator like this, I like to do the whole numerator first and then divide the answer by the bottom. Otherwise, I find kids tend to get too many numbers and there's syntax errors. So if this really big massive number, so 2.8319, that E means exponent for 10 to the 16th. So from there, I'm going to divide that number. I'm going to do two sets of parentheses, and you'll see why in just a second. One of them is for my 6.38 times 10 to the 6th. The other one is simply to square that. Otherwise, what you'll end up doing, you'll square the whole system before you divide. So we've got to make sure we include that in the parentheses. I'll hit enter. And it gives me an end result of 695.7. I'm going to round that to 74 newtons. Okay. So 695.74 newtons. All right. So there's my answer for that first one. Go ahead and flip the page over for me, please. And look at that. You've got a 3.3 kilogram watermelon. You're going to follow the same steps. So for A, it's the equation. B is the equation with the numbers. And C is your answer with unit. I want you to see if you can do A for me at the very least. I don't expect you to be able to do B, and C would be crazy to do in your head. But C, can you do just A for me? Go ahead, pause the video, and let's find out. All right. While you were gone, I recorded this. Actually, I also paused the recording. Now what I'd like you to do is to see if you can fill in those equation numbers. So for that one, I'm not going to pause and then pop them up on the screen. I will actually go over those, but I'd like you to take a second to pause and at least try to include one or two of them if you can remember where they go. Remember, I will always give you any of those crazy weird numbers. You don't have to memorize them, so feel free to flip back to that first page we did and look there for the constants. All right. So for our equation with numbers here, we're going to put in our value for G, which is 6.67 times 10 to the negative 11th, and that is in Newton meters squared per kilogram squared. Then I'll put in the mass of the Earth, which is 5.98 times 10 to the 24th power kilograms, times the mass of our watermelon, which is only 3.3 kilograms. Still a big watermelon, but not quite as big as the Earth. We're going to go ahead and divide that whole system out by the distance to the center of the Earth, which is 6.38 times 10 to the 6th power meters squared. All right, so we've got that bad boy set up. I'm going to have you plug that one into your calculator for me just because I've got to run to a staff meeting here in one moment. But it should work out to be about 32.3 newtons of force applied. So thank you so much for spending a little time learning to calculate gravity with me. I will also make a video for the acceleration questions in just a second, but again, I've got to run to that staff meeting. Hope to see you on the channel soon, and I will talk to you later. Bye.